Chapter 8 Projectile Motion 8.1 Horizontally projected motion. When an object is projected and moved freely in air, it performs projectile motion. In this chapter, we will investigate horizontally projected motion. 1. Vertical and horizontal motions. The monkey and hunter experiment is often used to find the relationship between the vertical and horizontal motions of the projectile. In this experiment, we aim the gun at the target on the other side, called the monkey. When the bullet passes through the switch, the circuit is open and there's no more current flow. The electromagnet cannot hold the monkey anymore. It falls. Let's take a look at the experiment.
Set up the monkey and hunter apparatus. The monkey is represented by a tin can. It is attracted by an electromagnet above it when the circuit is closed. Now we place the monkey about 1 meter away from the gun. Ensure that the gun is horizontal and at the same level as the monkey. Fire the toy gun. The bullet will break the circuit and the monkey will fall. Observe what happens to the monkey and the bullet. Will the bullet hit the monkey?
The bullet always hits the monkey. Why? Because they fall for the same vertical distance. But why would it happen? And what determines where they will meet? It is the distance d. In fact, a very important question you must ask is, how long will the bullet and the monkey be in mid-air? The answer is d over v. Distance divided by speed. A similar experiment is found on the next page. Let's take a look.
This wooden block has some markings on it. The markings have a fixed separation. We will release a metal ball from the top of the track. You may use a motion video analysis software to analyze the motion of the ball. Now we will release 2 balls at the same time, one from the upper track and the other from the lower track. The 2 tracks are identical except for their vertical positions. Observe the motions of the balls. Do the 2 balls collide with each other? What will happen if the vertical distance of the 2 tracks is changed?
So the 2 metal balls always collide. Why? Similarly, because they travel the same horizontal distance. But still, I have some more questions to ask. What determines where they collide? Where? It is determined by the height h, because height h will tell you how long ball A will be in mid-air. How long will ball A be in mid-air? In other words, how long does it fly? Let's find the time of flight. It should be. See if you know how to find it. So what do these 2 experiments want to tell us? In experiment 8a, the bullet and the monkey both fall for the same time, and so they travel the same vertical distance. They both accelerate under gravity. And even though the bullet has a horizontal velocity, its vertical accelerated motion is not affected. In the second experiment, the ball A is falling under gravity, but the horizontal motion of ball A is not affected. It travels with uniform horizontal velocity with the same speed of B. And now you may see, for the horizontally projected motion, the vertical and horizontal motions are independent. The horizontal velocity is uniform. It is not affected by the vertical accelerated motion. On the other hand, the vertical accelerated motion is also not affected by the horizontal uniform motion. Before we move on, let me remind you that the two metal balls should be released at the same height each, so that they have the same horizontal initial speed. 2. Horizontally projected motion. So, we can say a projectile is a combination of horizontal uniform motion and a vertical accelerated motion under gravity. So, we may calculate the displacement, velocity, and even acceleration for the horizontal and vertical components independently. For example, we may calculate the horizontal displacement using the equation for horizontal uniform motion. And for vertical displacement, we use the equation for vertical accelerated motion under gravity. Although the horizontal motion and the vertical motion are independent, they are still related by time t. In particular, the horizontal displacement and vertical displacement are related by this equation, which describes a parabola. This equation is called the equation of trajectory. Example 1 asks you questions about the trajectory. It applies the equation 2 and 4 to calculate the horizontal and vertical displacement of a horizontally projected motion. And then we plot a graph to see how its horizontal displacement and vertical displacement are related. And the graph is the trajectory. It's also the shape of the path of the motion. And now please do check point 1.